ABCD is a square. Consider the diagram below and determine with reasons the sizes of angles W, X, Y, and Z. Let's start with W. W sits over here inside angle A. We know that angle A is equal to 90 degrees because all of the interior angles of a square are 90 degrees. On our diagram, let's make this right angle red. Now we also know that AC is a diagonal, so let's make it green. We know that the diagonals of a square bisect interior angles, so we can see that W sits in one half of angle A. We know that A is 90 degrees, so we can see that W must be equal to 45 degrees. And as our reason, we say the diagonals of a square bisect interior angles. Now we can make our diagram black again. Let's tidy up our page. And we can put 45 degrees into our diagram at W. Now we can look at X and Y. X and Y both sit over here along with the 45-degree angle that we just found in triangle AOE. So let's make this triangle blue. We can see that AE is equal to AO. So let's make a note of this. We can say AE is the same length as AO because this has been given to us in the question. This means that triangle AEO is an isosceles triangle. AE is equal to AO, which means that angle X has to be equal to angle Y because these angles lie opposite equal sides. Now we can use the interior angles of triangle AOE to find the values of X and Y. So we can say in triangle AOE, we know that 45 degrees over here, 45 degrees, then we have X and Y. So we say plus X plus Y will give us a total of 180 degrees. And as our reason, we say because these are the interior angles of a triangle. We've just said that X is equal to Y. So in our equation, we have 45 degrees. Then we have X plus X, which gives us 2X, which is equal to 180 degrees. Now we can solve for X. On the left, we have 2X. Let's move 45 to the right. 180 minus 45 gives us 135 degrees. Now to get X by itself, we divide both sides by 2. Let's grab our calculator. 135 divided by 2 gives us 67.5 degrees. So we can see that X is equal to 67,5. We know that X is equal to Y. So if X is equal to 67,5, then Y is also equal to 67,5 degrees. Now we can take the blue triangle out of our diagram. Let's put 67,5 degrees in for X and for Y as well. And now we can make some space. Now we can find the value of Z. Z sits inside angle O, along with the angle of 67,5 degrees, which we just found. We know the diagonals of a square are perpendicular, so this whole angle must be 90 degrees. So let's put a right angle into our diagram in red. This means that 67,5 degrees plus the unknown angle of Z will give us a total of 90 degrees. And as our reason, we say because diagonals of a square are perpendicular. So to solve for Z, let's subtract 67,5 from 90. Let's grab our calculator and we say 90 degrees minus 67,5 is equal to 22.5 degrees. This is the size of Z.